Okay, good afternoon. So we'll discuss today pile design. So here's important note that you are going to take into consideration when you are designing a pile. So you have the ultimate bearing capacity QU is dependent on its base resistance here. This okay. You have here the base resistance, and then QS, which is the resistance along shaft. In other words, you have here the resistance at the base or the end of the pile, and then at the sides or at the shaft, okay, or the skin of the pile. So it would be dependent on the types of the soil. So for example, you have your cohesive soil like that of clay. You have this formula. This is the undrained shear strength at the base of the pile, stands for CB, and then the NC, which is usually taken as 9.0, and then the area of the base or the section of the pile, which is just pi d squared over 4. That's the area of the circle actually. Okay, then you have in the shaft, for the shaft you have here CA, undrained shear strength along the pile, and then AS, which is the area on the surface of the pile or this side. We simplify this further, like you have here this alpha, which is the adhesion factor, which is ranging from 0.3 to 1.0, and then the average undisturbed undrained shear strength along the piles. For example, if this is the pile, so the average, like if you have your 0 and then you have here there's a CU, so CU here for example is 40, so 0 plus 40 over 2 is the average. Okay, then you have here, for example, here is the area of the shaft, okay, at the sides. So at the sides you have the circle. If it's a circular section of the pile, the circumference is pi d, and then you multiply it with the total depth, so let's say L, so that becomes pi dl is your area of the shaft at the side. So we simplify this using this formula. Here is for the base, and this one is for the shaft. Now if you have cohesive granular soil, just like gravel or sand, you have here the overburden pressure, that is for the base, and then NQ, the bearing capacity coefficient, and then the area of the base. So this one differs with that of the cohesive soil. Alright, now for the shaft, which is FAs, and then area at the side, FAs could be simplified with this. KS is the coefficient of earth pressure, which is dependent on the type of soil. 1 for loose soil, and then 2 for dense soil. And then you have here, of course, the average overburden pressure, the pressure at the top and the pressure at the specific point, and divided 2. Okay, that gives you the average effective overburden pressure. This is the angle of friction between the pile and the soil, which is usually taken, this delta, as 0.75 of the phi, or angle of friction. Alright, so for example, you have here, this is undrained analysis. That means this is one for clay. You have here a 400 mm diameter. 400 mm diameter. The length is 6 meters. Then the test result says that there is an undrained. This one is already average. So you have here the average undrained shear strength, and then the length is 6 meters. At the base, the undrained shear strength at the base is 160. Okay, and then ends is given, then alpha is given. Okay, so at the base you have is CB, which is already given 160, ends is 9, and then area of the base you have diameter is 0.4. This is pi d squared over 4, area of the circle. So you have here the base, and at the shaft, since this is cohesive type of soil, you have this one's already given. Okay, so okay, at the shaft, this is the formula. Average, it's also given, and then area of the shaft, or the skin and the sides all throughout, pi d and l. So summing up the base and then the shaft will give you the ultimate bearing capacity of the pile. Easy for just one layer, but of course in the actual it should be a multiple layers like this one. Okay, for example, here you have the first layer is 3 meters of granular soil, loose, That's why KS is 1. This is the unit weight and then the shearing angle. The next layer has 4 meters, but this one is dense. That's why KS is equal to 2. This is the given value taken from laboratory results. And then the last one is cohesive type of soil, which is clay, the third layer. At every point, like for example, this one is at 3 meter, this one at 4 meter here. So 4 meter, I should say this one is 7 meters, I should say. At 7 meters, this is the undrained shear strength. At 8 meters, this is the undrained shear strength. At 11 meters, maybe here, this is the undrained shear strength. Take note that this one, this is granular, and this one is cohesive. Okay, here we are going to explore what would be the ultimate bearing capacity at the depth of 8 meters and then at 11 meters. So first, in the first layer, which is 3 meters, this is again, as I said, granular, so this is the formula. So area of the shaft is pi d L. K is for loose type of granular soil is 1, and then this one is the average. Actually here this is 0, this one is like 20 times 3, so you can just have, it's the same as 0 plus 60 over 2. It will still give you 30 average overburden pressure. Okay, so tangent 0.75 of angle of friction. So the ultimate bearing capacity at this shaft for a 3 meter depth of loose soil is 15.6. Now for the next layer, which is gravel. Okay, so again pi d, it differs only here because L here is 4 meters. We have already here 4 meters. And then you have K is 2. At this point, this one is 60. Okay, now this is not 42. Okay, because here you have like 21 times 4 will give you 84. Okay, so the average here, supposedly average here at this point is 0 plus 84 over 2, and that gives you 42. It is just like this one. This is 42. Okay, but then you are going to add 60 because at this point it's already 60. Okay, so 60 plus the average here. Okay, the average. Okay, plus tangent 0.75 of angle of friction. Then this one will be the ultimate bearing capacity at the shaft for this 4 meter gravel, layer. And then in the you have here a 1 meter thick at the clay for the shaft that we are also going to calculate. Now the formula for cohesive soil is this one. Okay, so you have alpha, average is between 7 meters and 8 meters is 120 and 145. You divide it 2, that becomes average. Okay, the area of the shaft is pi d, L is 1 because that is between 7 and 8 meters. That makes a 1 meter depth. So the shaft of 1 meter depth for the clay, this is the value of the bearing capacity of the shaft. Now at the base, since this is one is cohesive type of soil, so you have this formula CB at 7 meter, 8 meters should say is 145. That's why we have here. NC is given to be 9, and then area of the base is pi d squared here, pi d squared over 4. Our diameter is 0.5. Okay, so this is the bearing capacity at the base. Now let us analyze at 11 meter depth. So at 11 meter, this is just like, this is a 7 meters, then at a depth of 11 meters. So you have here a total L of 4 meters. We need this one because first you have CB is 20, that is at 11 meters. At 11 meters, the bearing, the undrained, the shear strength is 220, and is given to be 9. Okay, area for the base is 0.5. Okay, that is for the bearing capacity at the base. Now again for the shaft, you have here, okay, between 7 and 11 you have 120 and 220 divided to, that becomes the average 120 and 220. Okay, and you have pi d L is the distance between 7 meter and 11 meters. So that's why you can have this value of this bearing capacity at the shaft between on the clay, the layer of the clay, from the 7 meter to 11 meter deep, which is actually, as I said, part of the clay. So as I said again, this one is cohesive, granular, and granular. Now we sum up those values that we have calculated earlier. You have 256.2. This is at the bearing capacity of the base, which we have already calculated here. This is 256.2. Okay. Then the previous values that we already calculated, which is 58.6, 632, and then 124.9. This will be the bearing capacity at the depth, ultimate bearing capacity on the pile at the depth of 8 meters. Now at 11 meters, again, at the base is this one. And then the same through it here, like this is the granular soil, this loose and then the dense, this one. Okay, 58.6 and 632.1. And then you have 640.9, which is this one. This is the bearing capacity at the shaft or at the skin for the cohesive type of the soil, which is clay. So as you can see here, as you go deeper at 11 meters, the value of the ultimate bearing capacity is bigger, logically, as we expect. This one should be bigger than the bearing capacity at the depth of 8 meters. Okay, so that's all for the bearing capacity on pile. Next video will be on the bearing capacity of pile using Eurocore. That's all. Thank you.